Water has a high specific heat. In other words, it takes much more energy to raise the temperature of a set mass of water than it does to raise the temperature of an equal mass of dry air, aluminum, iron, or gold. In joules per kilogram per degree Kelvin, we have 126 for gold, 461 for iron, 880 for concrete, 921 for aluminum, 1,005 for dry air at sea level, and 4,182 for liquid water. Earth's oceans thus buffer the temperature changes we can expect from night to day and from season to season. We see this buffering effect when comparing the diurnal temperature differences along the coast compared to the deep desert. Coastal temperatures like those found in Suffolk County, New York, on Long Island, change comparatively little during the 24-hour diurnal cycle. For August, the average high is 78.9 degrees Fahrenheit, 26.1 degrees Celsius, and the average low is 65.5 degrees Fahrenheit, 18.6 degrees Celsius. That's a difference of 13.4 degrees Fahrenheit, 7.5 degrees Celsius. By comparison, deep desert Yuma, Arizona, with an elevation of 141 feet, 43 meters, has an August average high of 106.2 degrees Fahrenheit, 41.2 degrees Celsius, and an average low of 82.3 degrees Fahrenheit, 27.9 degrees Celsius. That's a difference of 23.9 degrees Fahrenheit, 13.3 degrees Celsius, nearly twice as much. Imagine if our world had no oceans. The daily temperature swings would likely be even greater in many locations because of the lack of clouds, and there would likely be no life to experience those swings in temperature. The thermostat effect. The oceans act as a thermostat not only because of water's high specific heat, but also from two other phenomena: evaporative cooling and cloud shading. The surface temperature is kept from rising too quickly because, as water evaporates, it cools the surface. That heat energy is transferred through condensation to higher altitudes. When the air becomes supersaturated at the cooler, higher altitudes, dust particles and cosmic rays trigger cloud nucleation events. This condenses the water vapor to form cloud droplets and that white fluffy stuff which blocks much of the sunlight aimed at Earth. In addition to the evaporative cooling of the oceans, clouds further cool the surface by blocking sunlight and bouncing it back into space before it can warm the surface. The rate of global warming is thus further dampened by the presence of water.